Hey everyone, so today we got a student who's working at a Santa Clara Pure Storage. Um, yeah, do you want to quickly just give a background on, or I mean, he was on here before, so I think what questions did I ask you?
So last time I was on here, I got asked the link list at numbers question and the check valid tree question.
How'd you do on those? Link list, add numbers.
The add number one, I solved pretty much immediately, and then the valid tree one, I came up with the two ideas, like the BFS to check it and the zero in degree to find the root, but I didn't combine them to get the optimal solution.
Okay. And you work in C++, right?
Yeah.
Okay, so we'll switch to language. Okay, that's good context. Now we need that will help inform us of what questions. What kind of jobs are you looking for post graduation? Are you trying to like do yeah, like what are your options?
Basically just interesting and high paying C++ work. So that kind of leads you to like distributed systems or databases and storage or quant, right?
Yeah.
So we'll see what offers I get and we'll see like what the scope of work and the pay is. But basically anything C++ and anything that's like high pay, I'm open to.
High pay is funny. Makes sense
Mhm.
though. You gotta make a living.
Yeah, exactly.
What if it's just high pay only?
I mean, it would have to be like if it's a really big difference, obviously, if it's like a 200K jump or something, then I would do probably something more boring like web dev. It
Hmm.
would have to be like a really big jump for me to willingly kind of step out of what I enjoy, which
What
is like C++
you really
optimization.
enjoy C plus plus?
Yeah.
Nice. You're different.
Mhm.
Um, cool. I'm gonna drop in the question. I haven't really worked with C plus plus, but so this is the first question since you're preparing for quant. We gotta give you some interesting ones.
Awesome. Like a turn-based game on a circular field surrounded by circle represents the field.
So I'll let you go ahead and read that and then try to clarify with it.
Okay. Okay, so yeah, there's this number of flowers in between them and clockwise, a number in between them anti-clockwise. Alice goes first and chooses one or the other. Has to compute number of possible pairs that satisfy the conditions. Alice must win the game. So they just they just choose a direction and pick a flower. They don't have to. It's not like a coordinates thing.
Yeah, they're sitting in a circular field.
Yeah, yeah, but they don't have to like move around or anything. They just like grab the flower at the turn. Following pairs satisfy conditions. 1, 2. I'm pretty sure Alice is just going to win anytime there's an odd number of flowers, kind of regardless of the sides. I don't think that really matters at all because how the game works is Alice takes a turn. She picks from the left or from the right, let's say, like clockwise or anti-clockwise. And then if there's no flowers left, then she wins, right? So she's going to go first. So that's going to be turn one, odd number, right? If she picks and then there's nothing left, she'll win. But let's say there's even numbers, so two, she'll pick. Then is Bob's turn. He picks, and he's going to win. So kind of regardless of if the flowers are on the left or the right, clockwise or anti-clockwise, doesn't really seem to matter. So I believe it's just if there's an odd number of flowers. So I think we have to just find a way, given the n and the m, to find out the number of what is it, pairs that add up to an odd number. So is it that? Let me double check though. Is it just if it's an odd number? So let's win the game. Number of flowers must be in the range 1 to n, 1 to m. Okay, so the reason this doesn't work is because, we can't choose 0. Okay, it has to be 1 to m inclusive. But like, if this was 2 instead of 1, then we could pick 2 and 1, which would be 3, and then this would be 1. Okay. So yeah, I think it's just going to be how many combinations we can get that add up to an odd number. So I guess I'll come up with a few examples and see if I can find a pattern. So let's see if we do like, start with something small that's easy to kind of manually work through. N equals 3, m equals 5. So what combinations can we get that are an odd number inclusive? It's just going to be, how do we get an odd number from an even plus an odd number? Because if we add 2 evens, we're always going to get an even. If we add an even and an odd, like 3 and 4, we'll get 7, which is always going to be an odd. If we add 2 numbers, like 3 and 3, we're always going to get an even. So what we need to do is we need to add n as an even to m as odd, or vice versa. So to get the number of, so basically for each even n value, so let's say like in this example we have 3, so the only even n value is 2. But for each of these, we can basically add 1 for each odd value of m. Mm-hmm. And then we know from 5 there is 3 odd values. Let's think, how did we get that 3? It's just going to be, okay, so if we do m plus 1 divided by 2. So if we do m plus 1, it gives us 6, divided by 2, we get 3. And then, but what if this was 4? If we do 4 plus 1 divided by 2, that will round down to 2, which is the answer we want, because we will have 1 and 3. And if we have 3 and we do 3 plus 1, that gives us 4. We divide by 2, we get 2. So it seems like this is the correct formula for odd numbers. This will also be true for n. And the number of even numbers, I think, will just be divided by 2. Let's think. If we have n2, we divide by 2. Yep. If we have n equals 3 and we divide it by 2, we should still want 1. That'll still give us 1. And if we have n4, we divide by 2. Yeah. So it's going to be number of evens, number of odds. And then we have to do this on both sides. So as we can see here in example 1, 1, 2 is valid, but so is 2, 1. So I think we just do return, we'll say n odds times m evens plus n evens plus m odds, which expanded out will be n plus 1 divided by 2 times m divided by 2 plus n divided by 2, this should be times, what was our odds formula?
So for C++, how does this division work? Does it divide up, truncate the value? Or
round towards 0, I'm pretty sure.
Just rounds towards 0? So
yeah, like we don't have to do the double slash if that's what you're asking.
Okay, so 5 divided by 2 equals 0.
Yeah. No, 5 divided by 2 is 2.
Sorry. Yeah, 5 divided by 2.
Yeah, if you're asking about double slash like Python, we don't have to do that. let me just check this formula holds. So let's see. We have this example here with 3 and 2. So what is it? So n equals 3, m equals 2. We want our answer to equal 3. And let's see, from our formula, what we'll get is, so 4 divided by 2. So 2 times 1 plus 1 times 1, which will equal 3. So it does seem to work. And then let's check example 2. It would be, so example 2, we would get 1 plus 1 divided by 2, which would be 1 times 1 divided by 2 is going to round to 0, plus same on the other side, which equals 0. So it looks like this formula does work. Yeah, so I guess let's probably code it up and write some test cases to confirm that.
Yep.
So should it return an int or like a long? Like how big is this? Constraints are n, so 10 to the 5 times 10 to the 5, yeah. We'll do long to be safe. So long, what are we even being asked here? We'll just call it possible pairs. Possible pairs given an int n and an int m. And our formula was return n plus 1 divided by 2 times n divided by 2 plus n divided by 2 times n plus 1 divided by 2. And then let's make some test cases. So like this 3 and this 5. Yeah, well, actually, let's start with the example ones. So let's do it, possible pairs. What was the example? It was 3 and 2, and then 1 and 1. So we should expect to get 3. Yeah, we should expect to get 3 and 0. We move this on to a new line actually, so it's easier to read. Yeah, so we do get 3 and 0 as we expected. I guess let's try out a bit of a harder one. Let's try and think of a possible edge case here. So, I mean, the edge case of both ones, we kind of already went over. I guess, yeah, let's try 3 and 5.
Let's see. Yeah, this makes sense. Let me just run it on the thing just to make sure you get it correct.
All right.
Yo, Faye, what's up? You're getting the wrong answer for 4 and 4.
4 and 4. Okay.
Yeah, you're getting, so yeah, I'll let you debug that. You're getting, expected is 8.
4.
Because I wasn't sure how
C++
is like rounding and stuff like that. So.
Okay, so 4 expect 8. So why do we expect 8? We should, because there's 2 odds and 2 evens for each, so that should be 2 times 2, which is 4. Yeah, so it should be 4 on both sides to get us to 8. So n plus 1 divided by 2 should be 5 divided by 2, should give us 2. M divided by 2 should give us 2, which should give us 4. What is it giving us right now? 9. Okay, so
like how many even numbers is in here in a 4 supposed to get?
2 and 4.
Or odd numbers. Yeah.
Also 2, 1 and 3.
Okay.
And then let's check this. So 2 and 2, okay. And then so we're getting 2 and 2. And then we should still be getting 2 and 2 here. M plus 1 divided by 2. And M divided by 2. These should all be 2. They are all 2. What?
These are all supposed to be 2.
Okay, it was some weird order of operations thing. I'm just going to wrap it in brackets.
Let's see. You run it on the code. Yeah, interesting. Wrap it in brackets. Submit. Give me the wrong answer. For 4 and 3?
For 4 and 3 now. What's going on here? 2, 2, 2, 1, 7. Yeah, so let's see. Our number of odds
I
for
think the only thing that
4.
could go wrong is M plus 1.
Yeah.
Plus 2. Or like M plus 1.
Well, so M plus 1 should give us.
Let's test it on a few examples. So let's just have, like, how would you test that doing plus 1 divided by 2 yields the right thing?
So with 3, what we want is we want to get the number of odds. So we want to get, obviously, in from 1 to 3, there's 1 and 3. So we want to get the number 2. So 3 plus 1 is 4. And we divide it by 2, which should give us 2. So what we would expect from 4 and 3 is, we would expect 2 evens and 2 odds in n, which it looks like we're getting. We would expect 2 odds.
Okay,
and
pretend I had
even.
3, right?
Yeah.
So if I have 3, if I'm calculating the number of odds, it goes 3 plus 1 divided by 2. It says 2. There's only one odd.
Well, there's 1.
Oh, there's 2?
There's 1 and 3.
Okay, 2. There's 2 odds.
Like if we look at the.
Wait, should it be inclusive? Trying to see.
It looks like it's square brackets. It says 1 to n and 1 to m.
I don't know what. Okay, wait, let me think.
What is it?
Yeah, there's 1 and 2. So that's okay. What about
Yeah.
if we do 3 for even? What is 3 for even? 3 for even, you get 3. 3 divided by 2. What is this going to equal? It should equal 1,
1.
right? What does your code
Yeah.
make it equal?
Yeah, it's 1. If you look at the debug output, we're getting 2, 2, 2, 1, 7. 1, 7. Okay. What of these isn't right then? Okay, so we want this to be doing is it this not being wrapped again?
Maybe if we just make some variables.
Okay, yeah, it's wrapping them again.
Yeah.
Yeah, I guess. Yeah, some weird order operations. Yeah. Yes, yeah, we could have put them into variables. So.
Let's see. It should. Okay, well, let's move on to the next question. I think you have it right. It's just it'll probably work now. It's just now we just know it's the order of operations.
Yeah.
Let's move on to the next question. So we're gonna be given a list of n cities connected by some number of flights. We're given an array of flights where flights is pretty much a flight between two cities and the price
Hmm.
to fly. It's essentially describing our graph. So this, I'll show you. I'm gonna post in the example here. So our source. So we're gonna be given a list of flights, right? So what it's saying is zero. We can fly from city zero to city one for $100. We can fly from flight or city one to city two for 100. City two to zero for 100. These are unidirectional. Like it's just showing the flight. It might not be. I'm not sure. Oh yeah, it might not be the same going back. This is just one way. Um,
Hmm.
yeah. So we have a list of different flights between cities and the price, and then we're also given a source and a destination. So we want to fly from source zero to destination three, and we want to
All right.
do it within k stops. So this one we want to do it within one stop. What is the cheapest price to get from the source to the destination?
All right. So this looks like a shortest weighted path within a graph problem. Um, so if there's no negative weighted edges, we should be using Dijkstra's. The issue with the default implementation of Dijkstra's here is that Dijkstra's makes the assumption that obviously the first time you visit that node, it is absolutely the best path. And while it will still be the cheapest price, let's say we visit node 4 for a cost of 5, but it took us 3 stops. There might be another path that brings us to node 4 as well, but for the cost of 6, but in one stop, right? So we actually can't mark it deterministically as visited the very first time we visit it, just based upon the price, because although that is like greedily, the best path, we do have to account for stops as well. So we're going to have to find some way to mark it as visited based on the stops and the price. So let's think. We still know the first time we visit it, it's going to be the cheapest price, but we don't know if it's actually the best in terms of stops.
Well, or we're optimizing for stops.
Oh, we're optimizing for price.
We're just optimizing for price, but we need to do it within k stops.
Yeah, yeah.
So if k is six, if there's a cheaper path that takes six layovers, like, we still take that path. It's still better, even if it's cheaper. Even though if there's one, that's one
Oh,
stop
yeah,
cheaper.
yeah. I know, I know. I'm saying that there might be, let's like, node 4 in my example was an intermediate node. So let's say, like, in that example I gave, that the K was 3, and we got to node 4 in 3. If that's not the finished node, then even though that's the fastest path to 4 based on price, we can't use that, right? Because we're already hit our K and we're not the destination. So let's say there's another edge from node 4 to 5, and 5 is our destination for the price of 1. So
Or
there's another
are you
path.
is there are you drawing somewhere or no? Just wondering.
No, I'm not
Oh, okay.
drawing. But like, what I'm saying is we need to account for stops as well, even though we're not optimizing for it.
Mm.
Like we'll still use Dijkstra's to optimize for the price,
Yeah.
but when we're checking adjacency lists and pushing into the priority queue, we can't just check if we've been to that node before, because for as in the example I just gave, we've already visited node 4, but
Yeah.
we can't deterministically mark it as like don't go here anymore because there might be another path to it that allows us to complete the problem.
Yeah.
Yeah. So now I'm just thinking about a way to like how I want to properly mark that as visited to account for that. So guess we could just do, let's see. So if we visited, what do we want to do? Visited, could we do we want to do a visited at K? K pride, K. Yeah, do we just want to do visited, like visited NK, which means we have visited node N at K, like at K stops. I should clarify, is K stops the number of nodes in the path or the number of edges?
Edges. Wait, let's see. Let me verify. No, it's actually nodes.
Nodes. Like including the source node?
No, that you have to travel. So pretend if I was traveling in the drawing here, let me go.
Where's the drawing?
If I was traveling from this source node to destination, I would have to this it would be 1. You go here, go here. So there's only one stop.
Okay.
One stop to get there. Like going direct is not a stop. You don't have to stop.
All right. So, okay, so K plus 1 is equal to max edges. Yeah. So K plus 1 is equal to max edges. We visited no. There's no done. Yeah, so I think what we're going to want to do is Dijkstra's, but instead of just checking visited, we will check. Yeah, we will have to do visited for K. And then like we can deterministically say that if we've already been there. Actually, wait, I don't think, maybe we don't have to do 2 dimensions here. We have visited, yeah. Let's say we'll call this unweighted distance. So at N, we have visited node N, like this, the value here will be, we visit node N at K edges. And then when we go to check through the adjacency list, we'll check if our number is less than this. So if our number is less than this, then we still push it as a possibility and we update it. But if it's greater than it, then we can pretty deterministically say, well, this is not a route we want to pursue, because this means we've already gone there in less unweighted edges, so less than K stops. And we have gone there in a shorter distance just based on how Dijkstra's works. So there would be no reason for us to pursue that path.
Mm-hmm.
So basically the steps we'll do is we'll build adjacency list. We will init our priority queue. We will init our unweighted distance vector. And then we will we'll push source, and then while not queue empty, hop front, check if at destination, check if, yeah, so the graph actually is going, what we're gonna need here for a value is gonna be our weight and the number, like the unweighted weight, basically. So it'll be weight, unweighted weight, and then just the node number. We'll call it that U. We'll check if at destination. We'll check if unweighted equals k plus 1. And in that case, we just continue. We can't pursue this any farther. We've already hit our max number of edges. And then we will like loop edge list u and push any like path worth pursuing further, which will be if weighted distance at v is less than uw plus 1. And then we'll just continue until we're at destination. And then what do we do? Yeah. And then if we don't do anything, we return -1 at the end. That would be our kind of logic flow.
What's W, UW, and U? Like what's weighted
So,
and weighted?
Yeah. Weight, unweighted, which is num edges and path. And then U, per node.
Weight
And then here,
weighted.
V equals adjacent node.
What's the unweighted for?
To check if this path is like worth pursuing. So basically in this like distance graph, the only reason why we would want to go to V and like continue down this path is if we either haven't been to V before or we have been to V before, but it took us more unweighted distance.
Okay. Like why not just label this number of edges or something like that? Like unweighted. Or like why do you pick that variable name of unweighted?
Like no specific reason.
Okay, I'm just wondering. Okay.
Like yeah, it could be anything.
Okay.
So does that make sense? The logic?
I think so. Let's go ahead and implement it and just figure out if it's all working.
All right. So what are we returning? Returning int. Let's say, what is this? Cheapest flight. And what are we taking in here? We're given vector int, which is flights. Vector. Okay, so basically, like I said, first thing we want to do is build our adjacency list. So first, let's get the number of nodes.
That's input as well. Like we're given 3 inputs: n, flights, and source, destination, and k.
Okay. Int n flights.
We're given flights. We're gonna be given the source, destination, and k. Yeah. And source.
Int k. Int source. Yeah. Int des. Wait, does it say n number? N cities. Okay. Yeah. So one second. Let me plug in my laptop.
Yeah, no problem.
All right. Okay, so we have n already. So what we're going to want to do then is make our adjacency list, which should be a vector of vectors. Basically, how we'll do that is we will just loop over flights. So for each thing in flights, what we're going to want to do is edge at f at 0 is our from. We want to push back the node we're going to, which will be f at 1, and then the price, which is f at 0. That should not be int, then it should be. All right, so there's our adjacency list, and then we want to initialize our priority queue. So priority queue of what did we say we wanted? We wanted weight like number of edges and node. So we'll have that as a tuple. So priority queue, then vector. And then we want, okay, so priority queues are normally max queues, but we want it to be min. So switch that. Priority queue greater queue. I need to include priority queues. And where do I include priority queues from? Priority queue. You. Okay. Okay, there we go. So initialize priority queue, and then pq.push, and we said so weight will be 0, edges will be 0, and then source. And then next thing we'll do is initialize our unweighted vector. So vector int unweighted distance n, and then we want this to be the max initially. What is this? Limit. Okay, so yeah, initialize our unweighted vector, and we want to push source. So we did that already. We're also going to want to send unweighted distance at source equal to 0. And then, yeah, well, queue not empty. So well, not queue.empty. What we are going to do is get from the front of the queue. So auto wait edges and u is equal to pq.top, and then pq.pop. And then we want to check if we're at distance. Okay, yeah. So if u equal distance, return w. And then what's our next check? Check if, if edges equal k plus 1. We cannot continue down this path any further, so continue. Yeah, and then we're going to loop over the adjacency list. So for in const v in edge u, if away distance at v less than, oh, we need two things from here actually. How do we make the adjacency list? It was v and then vw. So if unweighted distance is less than what? Less than edges plus 1, because that's what we'll be visiting this at. Right. Yeah, less than edges plus 1. Then away distance at v is equal to edges plus 1, and we can push this to the queue. So our queue is weight, so vw plus, so w plus vw, then edges plus 1, and then v. And then -1. Why is that saying that? Okay, so yeah, so we make our adjacency list. So from to thing, we make our priority queue, and we want the lowest weight at the front, and then we got unweighted distance graph, track distances. We put in a max initially because we want to have the smallest one. We put that in, put source in for both of them.
Mm-hmm.
Then we go through our queue, we get the weight, we get the edges it took us to get here, and we get the current node, and we pop it. If we're at the distance, we can return the weight it took us. If we can't go down this path any further, then we skip and try a different path. And we get everything from the adjacency list. We check if this path is worth pursuing. And if we do, we update it and we continue down. Oh, no.
So unweighted distance is, so we're only pursuing it if it got us there in less edges?
Yeah.
If it got... Okay, let's run down a few cases.
All right.
I'll just get some.
No adjacency list, unweighted distance source. Check if that is. All right. Two, 0, 100, 1, 3, 600, 2, 3, 200. Wait, what was K here? K is equal to 1. Source is equal to 0. This is equal to
This improvement 100 or 700. Oh shit. Error. The input.
oh.
So it's giving the wrong result. It's giving us negative
Yeah.
1.
Okay, let's see. Did I put this in right? N equals 4, flights equals 0, 1, 100, 1, 2, 100, 2, 0, 100, 1, 3, 600, 2, 3, 200. Then 4, source, wait, no, K equals 1. Yeah. Source equals 0, this equals 3. Okay. So yeah. Let's see. So okay. I guess let's check what it's actually doing here. It's only visiting 0. What? Why is it doing that? Oh, this is the wrong way.
Nice.
There. Okay, so
Running on the other examples.
yeah. Okay, so second example, N is 3. Then we'll update flights. Source will be 0. Destination will be 2. K will still be 1. But we're going to set flights equal to 0, 1, 100, 1, 2, 100, 0, 2, 500. The second one, and then this last one.
All right, let's go with the second one for now. Let's see.
All right. 500. Go. What, did I put this in right? 0. Was it source 0, destination's 2, k is 1. Okay, yeah, there's something. 0, 100, 1, 2, 100, 0, 2, 500. Okay, so it is initially at 0, 0, 0, which is correct. And then from 0, yeah, it should be visiting either this or this. Yeah, and it correctly visits this next. So we're at 1. Yeah, we're at 1. Yeah, we're at 100 weight with 1 edge and at 1. But then we go to 2 for some reason. Does this not get pushed? Oh, because we found. Okay. Okay, so this middle edge isn't getting pushed, even though it should be, because we found a path in less K. But yeah, it's not optimal. So how do we fix this then? Instead of only pushing it for unweighted distance, what can we do instead? I think.
Wait, distance is less than. Look, why are we only pushing it if it has less edges? That's the part that I was curious about.
Let me try this. There.
What did you add?
I moved where we mark it as visited, but let me double check that's actually correct. Okay, what I'm thinking, okay, the reason I'm doing it this way is what I'm thinking is, you know, that edge case I was trying to explain earlier, where like an intermediate path gets us there with less price, but it's not the actual best path because we took too many edges to get there. And there might be a more expensive path that takes way less edges that does actually allow us to get to the final. So we can't just do a straight up like visited or not visited kind of binary set because of that, which is why I'm doing it this way. You might get TLE with the cout statement in there.
I'm trying to just copying and pasting it. Give me a sec.
Yeah. 700, 200.
Run it on the last example. Let's see.
Yeah. 0, 100. 0, 2, 500. Source is 0. This destination is 2. K is 0. N is 3. Yeah, it passes all 3 that you pasted in here.
Wait one sec. Just getting a weird error when I'm posting in LeetCode.
Oh, it's because I'm using type aliases probably.
No, I had that. It was working initially, but find cheapest. Are you looking at the stream?
No, let me switch
over.
Let
me invite you to the LeetCode link. Pop it over. Posting it right here in the. Shit, the fuck. We're posting it into our meet.
All right.
Edges. See when I run that? Okay.
It passed. Yeah, you're missing a bracket.
Oh shit, where was I missing that?
This, if you can see where I'm highlighting right now, this one was missing.
Nice. Okay, sick. Good job.
Thank you.
Nice, nice. What do you think? How was that? How did that go?
Oh, I
Yeah,
think we
we're
went
pretty much
pretty
at time.
well.
Yeah,
Yeah. I mean, a little bit more debugging than I would have liked on both questions, to be honest. But I think in terms of understanding the questions, um, and like solving them, it went fairly well.
yeah, yeah. You were able to pretty much understand. Like the main thing that I seen people when I asked this one is they wouldn't understand to use Dijkstra's. I mean, you figured that out pretty much right away. It's like some people try a weird DFS solution, um, and then you understand that it's not just regular Dijkstra's. You're gonna have some slight variant to just
Hmm.
account for the edges. And and for the first one, I think it was good intuition to quickly find out that it doesn't really matter left side or right side. It just matters if it's odd or not. And then
Yeah.
finding out the equation to calculate how many odds given n and m. Right. The main thing was just the small issues with the way that you're combining it. Yeah.
Yeah. I guess if I separated that one out into variables, that one would have passed the first time.
Yeah, it would have made it probably a little bit
Yeah.
easier to look
Hmm.
at. Um,
Yeah.
and I
And then
wasn't
this
that sure
one,
with C++. I was because some languages when you divide, sometimes it rounds up. I think in Java, I don't even remember. There's some language where it round up. I don't know, but overall, no. I think you solved the question. That was good stuff. Guess next time we're gonna ramp it up even harder.
yeah, rounds towards zero. You can see even this
Yeah,
negative one
that
divided by
makes
two
sense.
is
Yeah,
zero.
or rounds towards zero. Yeah, that makes sense.
Yeah.
Okay, Mr. B said Java doesn't round up. Well, what I mean, rounds towards zero. So if it's negative, it goes up. If it's like positive, it goes down. I don't know how it works
Yeah.
in Python. I think it just rounds down no matter what, even if it's negative. It doesn't round towards
Like with
zero.
the double slash.
Yeah,
Yeah.
it's like weird stuff like that that you just need to worry about. But
Hmm.
no, I think you do good though. Next time we'll ramp it up even harder.
Yeah.
Yeah, cool. Sounds good. All right, catch you in the next one.
Perfect. Thank you.
Peace.
Peace.
Java doesn't round up. Okay, my bad, my bad, my bad. I don't use Java too much. Java doesn't round up even if it's a negative. I don't even know. On to right. Yeah, the way I did that is I would just divide and then take the ceiling. Nice, cool. All right, that's about it. Gonna enjoy my Sunday for the last little half. Probably gonna have to head into the office tomorrow, but